Today we'll be starting Venn diagram. Okay, what's Venn diagram? It's a graphic representation of a set. This is here. This is the Venn diagram. It represents for us the set. Here U is the universal set. This whole is the Venn diagram is represented in a rectangular form. That's here. U is the universal set. This whole rectangle is the universal set. And we have set A. This the blue circle here is set A, whereas the red circle is set B. So here what we're going to say in this universal set, A is a subset of set U because it's a universal set, right? It have all of these sets inside of it. That's why A is a subset of U. And if we consider only A and B, now here who's the subset of who? B is a subset of A. Got it? This is how, this is the same what we said yesterday. How can we write the subset of a subset of a set? It's the same thing, but here is represented in a Venn diagram. Now, complement of sets, okay? Complement set, I mean, sorry. It is the set of all elements of U which is not in A, that is, remove the elements of A from U. Okay, let's say here, for example, we have set U, we have it as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and what is set A from this set U? We have set A as 2, 4, 6, and 8. Okay, we need complement of A, means all the sets here that are present in A, we're going to remove them from U. Then we're going to get the complement. Okay, here we have 2, we're going to remove it. 4, remove it. 6, remove it. 8, remove it. What's remaining? 1, 3, 5, 7, 9. This is the complement of A. Got it? Complement of a set means the whole, this, the set of the all elements that's in U, okay, but not A. Got it? We have set U, we have sets here, we need, and we have set A. A is 2, 4, 6, 8. Complement is it, that we remove this set from the U. Got it? And it's represented by this symbol, A complement. If it's only A, means we know this is the set, the original set. But when it becomes complement, we write here like small, what we call it, quotation. Quotation at the beginning. Okay. Now properties of complement of set. The element should be from U, set U, as we said. If we're gonna take complement of A, they should be from the set U. We can't take it from any other set. It should be from the same set itself. Okay, and the elements should not be from set A. We said also here the same thing. The complement of A should not be from set A. See here, they're different. They're not the same elements because they shouldn't be the same elements. They should be complemented. That's not the elements themselves. These are the two properties. Here is a Venn diagram for complement of set. Here we have set A. This is U. That's the universal set. The complement is any set except set A. See, the complement is nothing that has a common in set A. What I'm saying? Is it clear here? Okay, we go to the next. Now operations of set. Now we're going to see how we're going to use these sets. Okay. First we have is the set union. What's set union? The union of two sets A and B is that set C, which consists of all those elements which are either in A or B, including those which are in B. For example, we have set A as 1, 2, 3, and 4. Set B 2, 3, 4, 5. Union of these two. Union is represented by U, capital letter U. Okay, the union of A and B, we're going to merge these two together, but we should not repeat the elements. Okay, the same element should not repeat. Here we have 1, 2. We're going to write 1, 2. We have here 1, 2, 3. We're going to write 1, 2, 3. Okay, here we have 1, 2, 3, 4. We're going to write the same 1, 2, 3, 4. Then here again, we have the same elements 2, 3, 4. We're not going to repeat writing it again. We just write the next element. That is 5. Union. We're just going to merge them together. But repetition is not allowed. We said that is the same set. Repetition is not allowed. We shouldn't repeat the elements. Okay, this is the Venn diagram. union. They merge together. All these to be considered, all of this in one set. That is the union of set. Okay. Now set intersection. Okay. The intersection of two sets A and B is the set of all those elements which belong to both A and B. Okay. For example, we have set A as A, B, and C. Set B is B, C, D. A intersection B. The intersection here means you take only the common. What's the common here between A and set B? BC, BC. So A intersection B will be BC only. We're not going to take A, no, we're going to take B. We need only the intersection here. As you can see, this yellow part is the intersection, the common, the similar one between A and B. Not the similar, I mean the common ones, A and B, both. We're not going to take anything else than that. Got it? And the Venn diagram is important. I feel like if you understand the Venn diagram, it will be even more easier to understand what's it. Yeah. And here complement is represented by, it's not N, but it's similar to N. Okay. Capital N, the intersection. Not capital, like the same N, but large. Opposite of you. Yeah. Opposite of you, upside down of you is the intersection. When it's only you, it's union, merging both of them. Union. But when it is intersection, it will be upside down. Intersection, A and B. Okay. Then we have set difference. The difference of set A and B in this order is the set of the elements which belong to A but not to B. Remove the elements of set B from A. Okay, for example, we have set A 1, 2, 3, 4. Set B 3, 4, 5, 6. We set A minus B. This is the set of difference of A and B. A minus B. So from the set A, here we have set A 1, 2, 3, 4. We're going to remove the elements of B. What are the elements that's present that are in A, B and present in A? 3 and 4. From the set A, we're going to remove 3 and 4. So what's remaining? Set 1 and 2. For it, A minus B. From set A, we're going to remove the elements that are similar, not the opposite. Now, when it comes to B minus A, we have set B. Set B is 3, 4, 5, and 6. Okay. From set B, we need to remove the elements from set A. What are the elements here that are similar? 3 and 4. So from set B, we're going to remove 3 and 4. What will be remaining? 5 and 6. Okay. As you can see here in the Venn diagram. Here, we have set A and set B. A minus B, that the sets from A, we're going to remove it. Sorry, we remove the sets that are present. Yeah, that's the common one. See here, remove the common one. What's remaining is only A without the one that's okay. Again, what's the difference? We're removing set A from set B or set B from set A. So when we have set A 1, 2, 3, 4, we're going to remove the elements A from B from A. What's there in B? That's are similar. Here 5, 6 is not there in B, so we don't care about that. We only care about the elements that's present in A and B that are similar. So the one in B is 3 or 4. So we're going to remove 3 and 4. Then what's remaining is 1 and 2. That is set difference. Very simple. Now disjoint set. Okay, what's disjoint set? If A intersection B, this is intersection A intersection B equals to a null set. This is the symbol of a null set, the one that I was showing yesterday as OI. Okay, this is a null set. Then A and B are said to be disjoint. Set A and B do not have any common parts. Here we have set A 1, 2, 3. Set B 4, 5, 6. We need the intersection. Intersection means the common. Here 1, 2, 3. Here 4, 5, 6. There is no common between set A and set B. No, not even one element common. So it's a null set. So this is known as disjoint set because there is no common elements in A and B. They don't share anything in common. Exactly different. There is nothing common except the null set. That is it. If there is nothing, so we're going to say null set. Here is the Venn diagram. A and B. See, there is nothing. They're not touching each other because they are similar. They have nothing similar. They have nothing common so that they can be joined together. Okay. Now application of set. Okay, is it clear till here? Because the next will be proving all what we took now and yesterday. Is it clear till here? Is it clear? Okay.
Yeah.
Okay. Now we're going to take how we're going to apply all this that we learned. Union, set intersection, set difference. We're going to take it now. Now the formula. Okay. Just let me open this. Okay. Okay. Well, here we have the first formula. Okay. Here. Now, first formula we have is N of A union B N of A union B equals to N A plus minus N of A intersection B. This formula, now we're going to use it as here N of A, we have it as we need to prove that N of A union B equals to N of A plus N of B minus N of A union B. Now, the question it could be given. The question could be given the values. What's N of A is 2, N of B is 3, N of A union B is 4, and N A intersection B is 1. All we need to do is just substitute the values. What is N of A union B? N of A union B is 4. What is N of A? 2. N of B? 2. Minus N of A union B. What's N of A union B? Intersection B? N of A intersection B? 1. 4. 2 plus 3, 5 minus 1. 6, 4. N of A union B equals to N of A plus N of B minus N of A union B. Sometimes we give a question, but we need to find what is N of A union B. Similarly, we can do the same intersection. Sorry, what's N of A intersection B? Simply, you can do the same thing. Just substitute the values, and you're gonna get the answer. Is it clear now? Is it clear? Okay.
Everyone, if you don't understand any part or anything that needs repeating, kindly you can unmute your mic and you can tell her so that she
Yeah, you
knows.
can ask now.
Yeah, so that she knows that which part you have understood and which you have not. There is nothing to
Can I
be
repeat it
shy
again?
about. Okay, you can ask anything. If any part you don't understand, you can ask her.
Sir, before the 2 plus 3 minus 1,
What is this? This is Y or 4 or 9?
4.
This is 4.
4. Yeah.
Okay. What is
It.
the meaning of this 4?
Huh?
What is the meaning of this 4? I mean, how you write?
Yeah, we wrote this because we need to prove that this formula works, that n of A union B equals to n of A plus n of B minus n of A intersection B. We're proving that this formula is correct.
Okay.
That is,
This is the proof for
I
the
will
formula.
clarify it a little bit. That we already know that n of A union B has 4 elements. Okay, so we
Yes.
are tasked with proving that this n of A union B, it goes by this formula. You can just calculate with this, like LHS equal to
Okay, I got
RHS.
it. That means,
Right.
so that means N A B A U B means totally 4. For 4 what means? That's the 4, right?
Yeah, they have 4 element. N of A union B. That means there are 4 elements in A union B, and in N is basically the number of elements.
Okay, great. Thank you, sir.
Please go ahead, Usna.
Okay, you can go now to the next question. Okay, the next question. We have two sets. We have set X and set Y. Okay, such that n of X union Y equals to 50, and n of X equals to 28, n of Y equals to 32. Okay, we have two sets, set X and set Y, and n of X union Y equals to 50, n of X equals to 28, n of Y equals to 32. We need to find n of X intersection Y. That's what we need to find. As we took in the previous formula, is that n of X union Y equals to n of X plus n of Y minus n of X intersection Y. Intersection. Okay, what we're going to do, just substitute the value. What is n of X union Y? 50. N of X 28 plus n of Y 32 minus n of X intersection Y. So it's going to be 50. 28 what's 28 plus 32?
60.
Yeah, 60. 60 minus n of X intersection Y. Okay, now take it to the opposite side. Here it's plus, so we're going to take it to the opposite side. Wait, no, wait. We're going to get a negative. We don't want to get a negative. No, we don't want to get negative. So what we're going to do, first we're going to take this to the opposite side. Minus n of X intersection Y. We don't want negative, we need positive. So we're going to take it to the opposite side. We're going to take it to 50. It's going to be n of X union Y plus intersection Y plus 50 equals to 60. Okay, we just took it to the opposite side. You know, we took an algebra. If we took to the opposite side, the sign will change. Here it's negative, it will become positive. This is already positive. Okay, now we're going to take 50 to the another side. Okay, so it's going to be n of Now here is plus 50. We're going to take to the other side. It's going to be minus 50. That's equals to 10. So what's the value of n of x intersection y? The answer is 10. Is it clear? Oh,
Okay,
yeah.
before she goes ahead, I would like to ask everyone, okay, one thing. So far, she solved the question. She has shown us some examples. Is it clear to you that what n union, n x union y and what n of x intersection y means? Is it clear to everyone?
Yeah.
Everyone, you can turn on your mic and you can confirm is it clear or not. If not, because unless until you understand what does that means, you will not understand what the formula is doing here.
As possible, please repeat again totally full structure as possible, please.
Okay, so in short, I will just explain that this part. Okay, so
Okay.
first of all, we have this x union y. Okay, so what is x union y? X union y is, let's say you have a set x, okay, and you have a set y. All right. Now, when you take the elements and both, like when you take both of the elements together, both the elements together of x and y, you get a universal set. Okay, the resulting set is going to be called a universal set. That's right, Husna, right?
Yeah, yes, it's a universal set.
Okay. Now, in x and y, the let's say in x there are three elements, 1, 2, 3. In y there are 5 elements, 3, 4.
I can write it.
Yeah, you can write it. Please do it.
X 1, 2, 3.
Yes.
And
Y
y
3, 4, 5. Okay. Also write x union y and x intersection. Yeah.
Okay, let me read this.
Yeah, please.
So I have space. Okay.
Yeah, write the values also for x union y and x intersection y. Okay, so now see, everyone, you can see there are two sets here. X, set 1 is x, set 2 is y. Okay.
Yes, sir.
Okay, so now set x has three elements, 1, 2, and 3. Okay, and then we have set y, it also has three elements, 3, 4, and 5. Now, if, as you know, in a set no element can be repeated, right? In a set, repetition of any element cannot be repeated. If there is 3 present in a set, you cannot write 3 again. Okay, so now when we are going to take a x union y, that means we are going to make another set which has elements from both these sets. So now we have 1, 2, 3, 4, 5. We are skipping 1, 3 here. In x there are three elements, in y there are three elements, but in x union y we do not have 6 elements, we only have 5 elements because we do not repeat any element. Understood? Whichever elements is repeated, we write it only once. Okay,
Okay.
you understand what a union means? Union means when you add two things as and make them one. Okay, so here we added two sets and made one. Okay, one big set out of that. In that, whichever part was getting repeated, we wrote it only once. Okay, so now the new set, that is x union y, it has 5 elements. Now there is another set, that is x intersect y. Now intersection means where two things are meeting, at which point they have something in common. Okay, so now which one is common here? 3, because 3 is in both of them. This is where both the sets are common. Okay, that is why x intersection y, that set has only one element, and that element is 3. Suppose that the main like the base elements x and y had, let's say it has 1, 2, 3, 4, and y had 3, 4, 5. So here X union Y would have been 1, 2, 3, 4, 5, and X intersection Y would have been 3 and 4, because in that case, in X and Y, 3 and 4, two of them have been common, because in X, if 4 was also present, so the 3 and 4 would have been common in X and Y. So that common, that is counted in X intersection Y. Is that clear?
Yes, sir, I understood.
So now this is what union and intersection means. Now she wrote a formula. Can you write the formula, Husna? Okay. Now, so far you understood what is union and what is intersection. Now there is n of X union Y. Now n means in X union Y, how many elements are present. Okay. That is what it means. For example, n of X means how many elements are present in X. So n of X is going to be 3 because there are 3 elements in X, set X. Okay. N of Y is also going to be 3 because there are 3 elements in the Y set. Okay. And then we have n X intersection Y. That means how many elements are present in the intersection of X intersection Y. So only one element, 3 is present. Clear?
Yes, sir.
Okay. And in X union Y, how many elements are there? There are 5 elements. So n of X union Y, there are, Husna, can you write 5 here down? Now you see how we can see the formula is actually correct. Now put the values for nx, 3, number of elements in X, again 3, yeah, and minus 1. Okay, so both sides you are getting the same answer, right? Is it clear now? Because earlier you asked where that 4 came from. So this is how that 4 came from, because we can see that if we put all the values in this formula, the left hand side is going to be equal to the right hand side. Okay, n is number of elements. Okay.
Okay.
Okay. Anybody has any more doubts? If yes, please ask again. This is why we conduct these sessions, so that we can clear our doubts.
So okay, one second. I'll clarify my doubt. This is 5 equal to 3 plus 3 minus 1. So how you write this minus 1 as possible, please?
Yes, I will tell you how. See, what is here minus in the minus place. If you look in the formula, it is minus n X intersection Y. That means in X intersection Y, how many elements are there? If you look above, how many elements are there in X intersection Y? Can you see?
1.
1. And how
Yes.
how that one element came? Because that one element was common in both of them. So whichever element is common, that goes in which section? It goes in the intersection one. Okay. If any element is common, that is excluded from the union, and that is counted in which one? In the intersection one. Okay. So in the formula, we wrote n of X intersection Y. That means the number of element in X intersection Y. So that is only 1, right? Above.
Okay, sir. Now I got it.
You got it, right? Okay. Anyone else,
Yes,
any
sir.
confusion? Or she can go ahead. If yes, you can turn on your mic and say. Otherwise, Husna, you can continue. Okay, please go ahead, Husna. Also, in 5 minutes, the session will discontinue automatically. So just click on the link to rejoin. Okay, everyone, because we do not have paid Zoom, we have free Zoom. So that's why there is a time limit of 40 minutes. So once the session disconnects automatically, you just have to click on the same link to rejoin. Okay, Husna, go ahead now.
Okay. Now last we have is Cartesian product of sets. The set of all ordered pairs, small a and small b, of elements, that is small a is element of big A and small b is element of big B. Let A and B be two sets. We said if A is element of small a is element of capital A and small b is element of capital B, then A, small a and small b denoted as ordered pair whose first comment is A and the second component is B. I'll explain that in an example. Okay. We have set A equals to 1, 2. Set B equals to A. Now we say A complement of B. The symbol that we write for complement is cross, like how we write in multiplication. A complement of B, like it's just like how we do multiplication. We first take we said A, so we're going to take the element from the first set A and the element of the first element, the second set B. So it's going to be 1A. Okay, now the second one will be again the second element, and here there is only one element, this element, that's 2A. This is A complement of B. Let's show another example. If we have set A as X, Y, and set B as N, M. Okay. A complement B equals to A complement B, we're going to take the element from the first set and the element of the first set from the second set. That's going to be X, N. Okay, now again the first set and the second. It's going to be X, N. Now we completed this. Now go to the second element, Y, N, Y, N, Y, M. This is A complement B. We're gonna take the order here matter. We can't go like first Y N then X M. No, we need to go in order. We're gonna start first with this first element and the first element. Again, the first element and the second element. We complete it, then we go to the second element with the first. Then again the first element, the second element. You got it? This is A complement B. Now if we need to write B complement A, the same question. Now with who is we're going to start? We're going to start with B. We're going to start with N. N, X. N, X. Then again N, Y. Oh, sorry. N, X. Then we're going to be N, Y. Okay, now we completed the first. Now we go to the second. First N, now we have M. M, X. M, X. Then we have the second M, Y. B complement A. Here the order matter, the order with which we go with the set matter. We can't jump from just an element to an element. We need to start the first with the first, then the first with the second, then again second with the first, and second with the second. Is it clear here? Complement?
Yeah, clear to me.
Everyone, you understood?
But I think in the first example, A cross B,
Mhm.
there is a mistake of brackets, I think.
Yeah,
These
the
should be
brackets here, they should be small, yeah. Okay, this clear now. Complement.
Yeah.
Okay, ma'am, done.
Okay. Now for this complements, you have some formulas. Okay. First formula is that if modulus of A equals to N and modulus of B equals to N, then modulus of A complement of B equals to N of N. Now, modulus is the Cartesian number of the set A and the Cartesian number of set B. Okay. I'm going to show that in an example. If we have set A as 1, 2, okay, and set B is A. Now, what is modulus of A? 2. And modulus of B is 1. Okay, as it's proved in the formula that modulus of A cross B. Now we need to find modulus of A cross B. Okay, first let's find A cross B. Let's see. What is A cross B? Like we see here. First element, 1A. Then if you the second, 2A. This is complement AB, complement of A and B. Okay, now modulus of A and B. Now what's the modulus? What's the number of elements here? This whole is one element and this whole is another element. So we're going to say 2. Now just substitute the value. Modulus of A cross B is equals to M. And that is what's A cross B we have here? 2. Complement. What's 2? Modulus complement of 2? The complement of A is 2 into modulus of A is 2, modulus of B is 1. 2 into 2. Sorry, equal. Clear?
Can you repeat this part again?
Okay.
No, just explain it. You have written it fine. Just explain it.
Okay. Okay. We have this is the formula. We are proving this formula now. Okay. We have modulus of A is M and modulus of B is N. That's the number of the elements.
Yes.
Okay. Then we need to prove that modulus of A cross B equals to
MN.
Modulus of A complement B, yeah, is equals to the product of their modulus. M and N is the modulus A, modulus B, the product, multiplication.
Yes.
Okay. For example, we have set A, it have element 1 and 2. See the element A. So what's modulus of A? What's the number of elements in A? 2.
2.
N number of elements, 2 here. Okay. And what's the number of elements in B? Modulus of B is 1. Okay. We have 2, we have 1. Okay. Now we need to find A cross B. That's how we said now A cross B, A complement of B. Okay. So we have first element is the first element, 1A. Then second element is the first element, 2A. This is we have for the complement, A complement of B. Now what is modulus of A complement B? We need to know the number of sets. Both of these are represented as one set. We don't say here 1, 2, 3, 4 sets. No, we don't say 4. We say 2 elements because this is one element, this whole is one element because they both are in brackets. Okay, and this also is one element because both of them are in brackets. Okay, so modulus of A complement B is 2. Now this is how we should prove the formula. They said the modulus of this complement is equal to the product of them separate. What is the product is the number of the modulus. That is m and n. What here we have m? We have m as 2 and n as 1. So 2 into 1 is 2. It's the same as then a cross b, modulus of a complement b, 2. Is it clear?
Yeah, it's clear now.
I can repeat it again if you want.
No, actually it is
anyone
clear.
need?
Oh yeah, anyone else?
Clear to me.
Okay, if no one is saying clear or unclear, you just go ahead. I
Okay.
think they are writing in
don't-
chat. Okay.
Okay. Yeah, this is the first formula.
Do you have a nice kind? This is a nice system of writing. You know, it's very innovative actually.
Yeah, I use this app for drawing. That's why it's
Because
easier to use. Like
for
getting
the
paper.
writing work, I bought a big board today, whiteboard. But if I have knew that I can do this, I would have saved the money on that board.
You bought a board?
Yeah, I bought a large board, you know, whiteboard.
Okay. Now the second formula said if
Sir, I want to say use something they are writing this formula or everything now. As possible, you save and you just upload as a PDF in WhatsApp group or in a portal.
Actually,
Then
this
after
entire
then
meeting.
anyone can.
Listen to me, bro. This entire meeting is recorded and uploaded on Telegram and YouTube. Okay. Alongside, PDF files are also uploaded in the Telegram channel. Okay. You can go and watch there. I think if you have the Telegram link after the meeting ends, you can see it in 1 hour. It will be there. Okay.
Okay, great. Thank you, sir.
Don't worry about that because we have that in our mind that things need to be recorded.
Sure, sir.
Okay, now I'm going to continue. Now here the second formula we have is that if A equals to B, then
I want to ask, has
A-
anyone recorded the first meeting today? Because I don't know what is wrong. Yesterday also one of the meeting was missing from my computer. So has anyone else has recorded the first meeting today?
Keep quiet.
What?
no.
Not me.
Okay, nobody did that, right? Because I was trying to save it. Okay, please go ahead, Husna. Okay.
Okay. Now the second formula, if A equals to B, then A cross B equals to A square. Why A square? Because we said A equals to B, just same as we say A into A. That is A square. Now we need to prove that. How is going to be proved? Okay. We have set A. It's 1, 2. Now we need to find A square. What's A square? Is A complement A. A complement A. Now we're just going to read this set twice. So we have set A square. Okay. First set. That's A cross A. That's the square of it. Is it clear here? It's just to show us that how we're going to use the complement if we have the same number repeated twice. The same set repeated twice. Say the same set have repeated twice. It doesn't make any difference with the complement. We use it the same. Because we said A equals to B. So A is A itself. B is A or A is B. Both are same. That's why we said A square. What's A square? A cross B. B is same as A. It's just the same element being repeated twice. So the complement of it is going to be square. Square of the product. Is it clear?
Yeah, these are equal sets.
Yeah, because both are equal. Both are same set. Okay.
Exactly.
Okay. Now
I
this
want
is
to
if
ask
we have
something
two
here, Usna.
elements.
If
Mm.
A is equal to B, then A cross B is equal to A square.
Yeah.
Okay, okay. If we, yeah, I understand. Okay, thank you.
As possible, please repeat again this part, because
Okay. Okay. We said if set A is equals to set B, means set A is same set B. Okay. Let's say here set A is 1, 2, and set B is also set B is also 1, 2. So we don't need to write set A again and B different. That's why we wrote them the same as B. Okay. So we set here A equals to B. So set A is 1, 2. Set B is 1, 2. Because both are equal, so we don't write, because we not write it as a square. If we wrote B, it would be hard to get it. That's why we wrote A into A. We substituted A and B. Got it? Because both are equal. Both are the same set.
okay.
Okay. Then we just wrote the complement of that A twice. Complement of A and A. That's we go
Okay.
first. Okay. That's we go first element, first element, first element, second element, second element, first element, second element, second element. That's how we got it.
Okay, great. Now I'm got it.
You got it?
Yes, ma'am.
Okay. Okay, now if we have three elements, that is A cross B, A complement of B complement is C. Okay, whereas small a element of capital A, small b is element of capital B, and small c is element of capital C. Then how are we going to write the complement of that? It's going to be A1
Turn off your mic, the guy who is eating. Yeah, please do that. Thank you.
Yeah, so here set A equals to, we don't have numbers, so we'll just try say A1, A2, A3. Since small a are elements of set A, small a are elements of capital A. So set A is A1, A2, A3, going on AN infinitely. Similarly, set B equals to B1, B2, B3, going on BN, and C equals to C1, C2, C3, going on Cn. So when we're doing complement A, complement B, complement C, we first we need to take the first element of A, B, and C. It's gonna be A1, B1, C1. We're gonna take the elements of the first, then again A1, B2, C2, then again A1, B3, C3. Now we completed A, we go to B. So now, sorry, go to A2, A2, B1, C1, then A2, B2, C2, A2, B3, C3. Now A3, B1, C1. It keeps going on because 3 elements, you know, we need to complete A, and after we complete A, we again go to B. 1, 2, 3. If we completed B, again we need to go to C. C, 1, 2, 3. Is it clear? We just need to go in order.
Okay, madam. Once again, clarify this. A1, B1, C1. Again, A1,
Element
B2.
of yeah. C2.
Okay. Next you write A1, B1, C1. What is meaning A1,
No,
B1,
sir.
C1?
No, it's 3, sir. A3. No, not here. A1, B3, C3. Okay.
Thank you,
For
madam.
A1, okay. Then again A2, it will be B1, C1. A2, B2, C2. A2,
B3.
now the same thing, yeah, B3. No, again
Okay,
we go for B3, A3. Goes on. After you complete A, we go to B.
Okay.
Is it clear now?
Yes. It should be going continue, right?
Yeah, it should be going on depending on the number of n, because here we wrote n, so we don't know till where we end. It just keep going on. But it have an end. It's a finite set.
So what is the exact number? Last number, last element.
Last element will be n.
An.
Yeah.
It's an infinite set, so it keeps on going like that.
This is infinite set now. It keeps going on. But if you keep a number instead of n, it will be finite.
In A cross B cross C, the after dot 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 dot, it's going to be A N B N C N respectively.
Yeah.
Okay, now I am got it.
Is it clear?
Yes.
Okay. That's all we have for the explanation. Now I'll give you some questions that I got, and we can solve it together just to clear all the doubts. Simple questions.
I think solving part should everyone should do it one or two in groups. They should try to solve it.
Just some simple questions. We have set A, B, C, D, and set B is 1, 2, 3, 4. Now the question is, are those sets, are they equal or equivalent? Sorry, equal or unequal sets? Sorry, are they equal or unequal sets?
They are equivalent sets.
No, I'm asking about equal or unequal sets.
David, can you answer that?
Who can answer?
They don't seem equal.
Why they don't seem equal? What make them equal sets?
Like if they have the same element ABCD and
Okay.
B also has element ABCD, then it is equal.
In
Number
equal
of
set, this wait. In
but-
equals. Yeah, continue.
So number of elements are same, but still they are not equal because they don't have similar elements.
Yes, so
Or
they are unequal because the elements, they are not similar. Okay. So if they are not, if they are unequal, what they're going to be?
equivalent.
Yes, equivalent. Why equivalent? Because the number of the elements is same. Here we have 4 elements. Here we have 4 elements. So they are equivalent set, but they are unequal sets. Now is it clear the difference between equal and equivalent?
Sure, madam.
Okay.
I think it would be good if everyone try to solve some things by unmuting themselves one by one. Okay, it will be good for you. It will
If
help
I-
you understand.
If I got some questions, I can send it in the group so you can solve it.
Yeah, that can also be done.
Now here we have set A. It's 1, 3, 5, 7. Okay. Now we need to write all the subsets. Subsets of element A. What are going to be the subsets? What's going to be the first subset? Who can say?
Null set.
Yes, it will be a null set. Then it's going to be 1. Then 2, 3. We're writing only the subsets. 5, 7. Then we'll go
1 second, madam. What do you write in subset A equal to break?
we're writing all the
stop.
subsets of A. Subsets
Okay.
of A.
Next, in closing bracket, what do you write? A or what this? What?
This is a null set.
Okay.
Theta, empty set. It's always there. It's a subset. Then we go 1, 3, 5, 7. Then we're
7.
going to pick 2 elements.
You
1,
need to close.
3.
You need to close the bracket.
No, still it's not closed. It's still open.
Okay.
We didn't finish. Yeah, 1, 3, 1, 5, 1, 7. Now again we're gonna we finish 1. Now we're gonna start. We're not gonna write 3, 1 because it's the same as 1, 3. Repetition of elements is not allowed in sets. Okay, so we're gonna go to the second. 3, 5. 3, 7. 3, 7. Now we'll go to 5. Are we gonna write 5, 1? Should we write 5, 1?
No, it's the same as 1, 5.
Yes, it's the same as 1, 5. So not gonna write 5, 1. We're gonna go to the second. Are we gonna write 5, 3? Again, no, because it's already present. 3, 5. So we're gonna write 5, 7. Okay.
So this element is same, so that element don't need to write, right?
Yeah, we don't write. We don't repeat the same element again.
Okay.
Okay. Okay. Then the last we have 7. Are we gonna write again 7, 1? No, we don't write 7. The same as 1, 7. The same thing goes for 7, 3. We have 3, 7. The 7, 5. We have it. Okay. Then we go 1, 3, 5. Then 1, 3, 7. Okay. Then 1 will finish. 1, 5, 7. We're gonna take 3. 3 we finished. Okay. 1, 5, 7. Okay, then we're going to go 3, 5, 7. Now, is there any possible sets? Are we done, or are there any more possible sets? Is there anyone here?
1, 3, 5, 7.
Yes, the same set itself. 1, 3, 5, 7. Now we can close it. Now those are all the subsets of set A.
That's possible. Can you repeat this last line,
Here.
which is from 1, 3, 5?
Okay. We finished. We take 2 pairs for each. We took 2 for each. Okay. Now we're going to start by taking 3. We start 1, 3, 5. Like same we have here. 1, 3, 5. 1, 3, 5. Then instead of 5, we're going to take 7. 1, 3, 7. Okay.
Okay.
Okay. Then we start with 1, 5, 7. We're not going to 3 already. We took it here and here. Okay. 1, 5, 7 with only 3, 3. Okay. Then we're gonna write 1, 5, 7. Then we can write again 1, 5, 3. But it's already there 1, 3, 5. That's why we didn't repeat it. We skip it. There is no need of repeating the elements. If you want, you can repeat all of them. Then you can start canceling. But that's going to be time consuming.
Okay.
Okay. We finished 1. We finished now. Then we're going to start with 3. 3, 5, 7.
Yeah.
3, 5, 7. Then we're going to be 3, 5, 1. Okay, but we already again have 1, 3, 5. We're not going to repeat. Okay. Then again 3, 5, 1. We said it. We're done with that. So is there anything possible? We already took 3, 3, 3 pairs for each. So what's going to be the last element? The last element is going to be the set itself. 1, 3, 5, 7.
Okay, I got it.
Is it clear? With practice, you can get it more. You just need to practice it.
So okay, I wanna say you that if now it's a number, if you write there any letter like small a, small b, small c, or small d, if it should be like same, right?
Yeah, it will be the same. Numbers or letters, they're the same.
And
What we
answer
did
should be
yesterday, yesterday what I did is that I keep repeating on them. That's why it kept going on and it took time. That's why if you don't repeat them, you just when you come to write the sets, you can see if it's repeated on it. So you can skip it and go to the next one.
okay. Great, I understand now.
Okay. Is it clear?
Yes.
Okay, can we go to the next question now? Okay, now we have set A. For set A, we have 1, 3, 5, 7, 9. Set B, 11, 2, 3, 13. We need to find first A minus B. That's A difference B. Now what are we going to do here? From set A, we're going to remove all the elements that are present, that are similar in set B. First, we write 3 the same. I mean 1, we're going to write the same. Then we have 3. 3 is present here. Yeah, 3 is not present here, so we're not going to write it. Then 5, it's okay. 5 we can write, it's not there. Then we have 7. 7 is not repeated here. 9. 9 is not present here. 9. Then 11. 11 is repeated. So we're going to cancel. Fine. This is A minus B. That's A difference B. Now if you need to write B difference A, that the elements that are present, all the elements that are present in A should be deleted from the elements that present in B. Okay. First we're gonna start with 11. 11. 11 is present here and present here. So we're not gonna write it. Then 2. 2 is there? No, it's not there. Write 2. Then 3. 3 is there. We're gonna cancel it. Then 13. Is 13 here present? No, we're gonna write it. This is A minus B. This is B minus A.
Yeah, clear to me.
Okay, madam. As possible, once again repeat from A minus B equal to A comma 5 comma 1 comma 5 comma 7 comma 9.
7, 9. Yeah.
You just repeat from there.
Okay. Okay. We said A minus B. That means the elements in A, all the elements that in B should be deleted from from the elements present in A. Okay. So we have first 1. 1. Is it there here in B? No, it's not there.
No.
All the elements
Second.
in B should be removed from the elements of A. Okay.
Okay.
All the elements that is similar in B and similar A should be removed. B should be removed from A. Okay.
Okay.
Then, okay, we start with 1. 1 is present in A. Is it present in B? No, it's not present. So we're gonna write it. Now 3. 3 is present in A. Is it present in B? Yes. We're gonna delete that. We're not gonna write it. We're gonna go to the next element. 5. Is it repeated here in B? No, it's not
No.
there. We're gonna write. Then 7. 7. Is it present here in set B? No. We'll keep writing that. Then we have 9. 9. Is it repeated here in B? No. We're gonna write that. Then here we have 11. Is it repeated here in B? Yes, we have 11.
Yes.
So we're going to cross that. We're not going to write it. That is A minus B.
Okay.
Okay, the same thing goes for B minus A. But here, the elements that are present in A should be removed from B. The similar elements present in A should be removed from B. Okay. In B first here we have 11. Is it present here in A? Yes, it's present in A. So we're not going to write that. Then again we have 2. Is it present in set A? No, it's not present in set A. So you can write it. Then we have 3. Is it present in set A? Yes, it's present in set A. We're not gonna write that. Then we have 13. Is it present in set A? No, it's not present in set A. So we're gonna write that. B minus.
Okay. I'm got it, madam.
Yeah.
Ma'am, I have a question.
Yes.
Live classes started or not?
No. Yes. I'm not the teacher. Guys, this is not the actual classes. You're just students collaborating and doing that. The live classes did not start yet.
I'm weak in English, so I can speak Hindi.
And I don't know Hindi. Can someone help?
Oh,
No.
you don't know Hindi?
भाई हेलो
Hello?
या लाइव क्लास यही है मगर ये यूनिवर्सिटी का नहीं है ये बच्चों ने करा है ओके
Okay, okay.
यूनिवर्सिटी का कब होगा हमें भी नहीं पता मगर कोर्स ये यूनिवर्सिटी का है ठीक है
Classes कब से start होंगी ये बता दो क्या आप एक बार भाई?
idea and don't ask here you can ask that in WhatsApp groups let her continue
Yes,
Okay.
madam. You continue, please.
Okay, now is this clear? Can we go to the next question?
Exactly, madam. Sure, please.
Okay, now this will be the last question. we have set A. It's 1, 3, 5. Set B, 2, 4, 6. 1, 5, 7. We need to find A union B union C. Now first we need to find this B union C. Like we know in BODMAS rule, we need to start with the bracket first. So first we need to find B union C. What is B union C? We have B and we have C. Union. We're just gonna merge both of them together. We're gonna write all of them. 2, 4, 6, 1, 5, 7. Here there are no like there is no similar elements. That's why we wrote all of them. If there is like here 1 and here also 1 is there, then we're gonna write once only twice, because repetition of elements is not allowed. Okay. Now A union of B union C. Yes.
Once again, repeat from A union B union C.
Okay, B union C. We're gonna write all the elements that are present in B and C, union of them. We're gonna merge them together, but repetition is not allowed. If there are similar elements, we won't repeat writing them twice. Okay. Now, what are the elements in B? 2, 4, and 6. 6. And what are the elements present in C? 1, 5, and 7. That's all. That's B union C. Union of both of these sets. Clear?
Yes, madam.
Okay. Now we need to find A union of B union C. Now we have here a new set. Okay. Now here we have a new set, B union C. Now this is what we need to find, the union of B union C and A. We need to find the union of these two, A and B union C. Okay. That's gonna be, now we're gonna start. Can start with A, because first we have A. What are the elements in A? 1, 3, 5. So what are the elements present in B? 2, 4, 6. Are we going to write 1 again? No, we won't write it again because we already have it here in the beginning. So we won't repeat it again. 5. Now, are we going to write 5 again? Similarly,
Yeah,
here we already have 5. We won't write it. 7. It's not there. Then we can write it. 7. Finish. This is A union of B union.